Okay. So, now what we have looked at is that the basic performance parameter, thrust coefficients, or the other important factors that affect those performance parameters. Now, we will go into the details of individual engines that we have talked about in the introductory lecture, like there are different kind of engines. So, the first one to start with is the piston engine and the propeller engines, and we have already talked where they are applicable. These are for low speed applications, they are very good, and how those system actually works. Now, we look at in terms of aerothermodynamic principles, and now onwards all this discussion would be more focused on the individual engines, like we start with piston and propeller, then we will move to the ramjet, scramjet kind of engine, and then turbojet and turbofan. So, this is how the plan is ahead before we move to the turbo machinery. So, let us start with the piston engine and propeller engine. So, now just to re-emphasize that any air breathing engines, so any air breathing engine, it requires some sort of an combustion system or combustion unit. Okay. So, and while carrying the appropriate fuel. So, the combustion chamber, the fuel is burned. So, what is the aircraft designer they want? They want to have higher thrust, higher T, and less weight. So, that means more and more lighter materials in that sense. Also, they want high thrust to weight ratio. So, the other goal is to less emission also. So, this typically connected with the combustion system, that you want less emission, small footprint, that is the size, less noise, and better cooling, lower fuel consumption. I mean such those properties which are very much important, and that is what already we have shown, that there are different kind of engines, and this particular engine there could be I mean the depending on that combustion unit, it could be intermittent type or it could be continuous combustion type. So, this is the combustion engine where this could be two different kinds. Now, here when we talk about the piston and propeller engine, piston or propeller engine, they are intermittent type, and when we talk about the continuous combustion system, then we go to the jet engine discussions of like turbojet, turbofan kind of engines. Okay. So, now all this engine, whatever it is, these engines, they need to basically fulfill certain basic norms. One is the efficiency, that means the engine must operate at the high efficiency under a wide range of atmospheric condition. Then it should be economical, it should be must be economic to produce, run and maintain, that means the engine manufacturing, this is what. Then the reliability. So, these are three major factors which are very important for any design and manufacturing of an engine. When you talk about the high efficiency, we talk about the less cost in fabrication and production, then finally it is a reliable, that the engine must be able to endure long period of operations at power settings without failure. Now, that brings to a simple questions, why are there are different types of engines. So, why are there different types of engines? So, one simple answer to that is that the engine is designed to fulfill the mission requirement. So, that means there are different mission requirements, for example, if you look at the cargo planes, they operate at the cruising condition mostly. So, for this kind of planes, thrust is not an important, as high engine efficiency or low consumption is important. Then again, if you go to like fighter planes or high speed aircraft, they require high excess thrust for their maneuverable quick accelerations, and for these fighter planes the engine efficiency is not as important like the thrust. Now, the modern military aircraft, if you talk about, then the engine efficiency is not an that they deploy afterburners and low bypass turbofan engines, so that the more and more. So, these are the thing what are different. So, that means the different kind of engines comes from the mission. That is the simple answer to that, the mission requirement. So, as per your requirement, the different engines are designed and they are in use. Now, intermediate combustion engine, we can look at how this could be, like this is an chart from early 2000 to 2032, the projection. So, these are sort of the can be identified as the aero piston engines, and it is like aero piston engines, and they are different from the automotive piston engines. So, they are classified into 3 different categories. One is the rotary type engine, reciprocating engine, and the supercharged or. So, they will be rotary type, then reciprocating, and other could be supercharged or turbocharged reciprocating engine. Okay. So, and these are, so we have already talked about when 1903 the first flight actually came up. That time it was an only piston engine which was used. Now, we can see the development since then. So, the development has gone really far, and we can see the things here like what you can see there. So, the essential milestone in 1903 is that jet engine which was invented by Frank Whittle, the Van Weyden, the piston engines were the only prime mover for their flight vehicles. Later jet engines and all this took over. Now, as I said, these could be 3 types: rotary, reciprocating, and supercharged or turbocharged reciprocating engines. So, now also these piston engines or can be classified based on the number of cylinders or method of cooling or cylinder arrangements. So, for example, 2 principal types of engine one can see. One could be the SI engine or the spark engine, ignition engine, which is pretty much the petrol engine or gasoline engine. The other one is the compression ignition type, which is the diesel engine. Okay. And the other options could be, this could be classified also like 2-stroke engine or 4-stroke engine. Okay. So, in a spark engine, here the fuel air is mixed and they are ignited by a spark plug, and these are the mostly the petrol engines which are used, and the premixing was formerly done in the carburetor. So, now it is done electronically controlled fuel injection except in small engines, and these SI engines are advantageous for applications requiring up to 200 to 25 kilowatt of power or something. Now, on the other hand, in the CI engines, this is compression ignition kind of engines where actually the fuel air mixture is injected to the system or the piston or inside the cylinder, where then the due to the compression process they gets compressed and finally the. So, these engines are more reliable and normally preferred for applications where fuel economy and relatively large amounts of power are required. Now, the new trend of diesel engines, they bring more fuel efficiency, lead also free emission to small aircraft, representing the biggest change in the light aircraft in the decades. Also, the CI engines or the diesel engine has the highest thermal efficiency of any regular internal or external combustion engines due to its compression ratio. So, now when you look at this, let us go to the one which we look at as the rotary type engine. Okay. So, this is an rotary engine. So, this is a conventional type. So, in the rotary engine, this was this is one type of internal combustion engine. So, which was used with the odd cylinder numbers and per row in a radial configurations. Also, the crankshaft remained stationary and the entire cylinder block rotated around it. So, this was widely used during World War I and the years immediately preceding the conflict. These are described as very efficient in terms of power output, weight, cost, manufacturing and reliability. So, this is one of the sort of an genome engine. So, these engines are also sort of an two-stroke design, giving them high specific power and power to weight ratio, but there are certain problem like the severe gyroscopic effects from the heavy rotating engine made the aircraft very difficult to fly. Okay. So, that was the sort of an awareness it was there during that time. Now, there is another one which is called the Wankel engine, which is of 4-stroke type. So, this is a 4-stroke Wankel engine. So, this having odd cylinder numbers per row, World War I, 2-stroke, and this is another type which is called the 4-stroke of Wankel engine. So, Wankel engine is also considered for optimum power plant for lighter aircraft, and it is light, compact, almost vibrationless, and you can see this is how the 4 strokes. So, 1 stroke the intake comes in, then the compression, then ignition and then finally the exhaust. So, this engine include rotors cannot cease since rotor casing expand more than rotors, not susceptible to shock cooling during descent, does not require any enriched mixture for cooling and as such like that. So, this was also popular in experimental aircraft in early days, and now since the Wankel engine are also becoming popular in experimental aircraft, like some lightweight aircraft like this ARV, and some aircraft like for this kind of Midwest twin rotor engine. So, these are the some of the design which are recently using this kind of engine. So, the Pratt & Whitney is also developed a diesel Wankel engine for use in prototype VTOL flying called the Transformer. The engine based was called earlier UAV diesel Wankel concept called EnduroCore. So, these are the some of the development and where the Wankel engines is in use. Now, the other thing what could be, so we can have the reciprocating engine in a different varieties, like you could have now reciprocating engine, you can have inline engine. So, this is based on the cylinder arrangement. You could have horizontally opposed engine, you could have V type engine, you could have X type engine, you could have H type engine, and then also radial type. So, these are based on the cylinder. Now, inline engines, you could have horizontally opposed V type. There are different kind of engines which are possible, and some example we can see, like this is one of the radial type of engine, where you can see this picture that there has one or two rows of cylinder and arranged in a circle around a centrally located crankshaft. Each row must have an odd number of cylinders in order to produce smooth operation. Rotary and radial engine look strikingly similar when they are not running, but can easily be confused since both have cylinder arranged radially like this direction around a central crankshaft. Unlike the rotary engines, radial engines use a conventional rotating crankshaft. So, this uses conventional crankshaft. So, that is important. Now, another type could be this turbocharger or supercharger kind of, this is a Rolls-Royce engines, where you can see you have a compressor, then turbine wheel, and how the cylinders arrangement is done, and when they are. So, this is a typical layout, and this is a. So, these are also another category of engines, or this kind of intermediate combustion engines which are available for these things. Now, when you go to the aerothermodynamics of the, let us say we start with the, so this is a typical nomenclature of any reciprocating engine. So, what you have the cylinder which is connected with the crankshaft here, and the crankshaft which rotate. So, this cylinder with the piston head, a cylinder with this piston actually moves up and down, which creates this reciprocating motion, and then there are spark plug, there are valve which is used for the intake and exhaust. There is a, then these are the nomenclature like stroke, bore, bottom dead center, top dead center. So, this is a bore, this is the bottom dead center, that means the cylinder goes below up to that top dead center. So, there is a clearance volume, intake exhaust valve. So, there is a the compression ratio or RC. So, the compression ratio which is defined as V max by V mean, which is V bottom dead center by V top dead center. So, that is the ratio of that. So, any 4 stroke internal combustion engine. So, what happens that when the so that is an these are some of the nomenclature, and then you can see how this happens, and this is the pressure versus velocity plot. You have a intake stroke where actually the valve is open, intake valve is open, and the piston actually moves downward to get the fresh air inside the cylinder. For spark ignition engine, this charge is combustible mixture of fuel and air, and compressor engine ignition engine, it would be the air only. Now, that second, with both the valve closed, the piston undergoes a compression stroke. Okay. So, this is where the compression takes place and raising the temperature and pressure of the charge. This requires work input from the piston to the cylinder contents, and combustion is induced near the end of the compression process. That means, when the cylinder reaches towards the TDC, top dead center, and this is achieved using a spark plug in the spark ignition engine, or in compressor ignition engine, the combustion is initiated by injecting fuel into the hot compressed air. So, when the fuel is injected there, the gas is so compressed and hot, the fuel gets evaporated and the combustion occurs. So, that is what it happens. And then this is the power stroke or expansion stroke. So, during which the gas mixture actually expand, and again the cylinder piston moves towards the bottom dead center, and then finally in the exhaust stroke the piston moves back. So, there is one is intake, 2 is compression, 3 is power stroke, 4 is the exhaust stroke, and this is how the valve operates. This is at the intake, and then it goes where the ignition, this is where your this region where the combustion takes place, and then again in the expansion stroke. So, this is the typical pressure velocity diagram. Now, when we try to do this analysis, so we can do air standard analysis, and for doing that, some of the things for air standard analysis. So, there could be a simple procedure. So, one, it could be a constant pressure intake, and exhaust strokes are also assumed to be constant pressure intake and exhaust. So, it could be at wide open throttle or fully open throttle valve. The intake stroke is assumed to be at constant pressure which is there, and partially closed throttle or with supercharged, the inlet pressure will assume a constant value other than. Second, this is for air standard analysis. These are some of the assumption. All the process are internally reversible. So, that helps us to. Now, third, the compression and expansion strokes are approximated by isentropic process. So, the compression and expansion, they are isentropic, that means reversible and adiabatic. So, sometimes the lubrication minimizes the friction between the piston and cylinder walls, and fourth, the compression process is replaced by a the combustion is replaced by a heat addition process, heat addition process from an external source at process for SI engine, V constant or rather volume constant and compressor engine pressure constant. And 5, exhaust blowdown is approximated by a constant volume. So, exhaust is also constant volume process. Now, in air standard cycle, air is assumed to be ideal gas. So, that means we can write P equals to rho R T, we can write dH equals to Cp dt, we can write du equals to Cv dt, all also A is gamma R T. And for isentropic process, we write P v to the power gamma is constant, and what else, T to the power V gamma minus 1 is constant, and T p 1 minus gamma by gamma, which is constant. Now, similarly, the work done for isentropic process from state 1 to state 2, this is let us say W 1 to 2, P 2 V 2 minus P 1 V 1 by 1 minus gamma, which is R T 2 minus T 1 by 1 minus gamma. So, these are the some basic assumption for air standard cycle, and now with this assumption we can actually look at the cycle analysis, and we will do that in the next session.